part of the inspiration of this entire project for me was a machine learning competition on Kaggle.com, where they gave this data for all power plants on the island of Puerto Rico, as well as some emissions data, atmospheric measurement data for nitrous oxide for a 1-year time frame. And that basically set me on the path of how do I get this data across the world? What about where I live? So the whole point of the competition was not just to look at the data, of course, but to give the world the opportunity to help solve a problem in measuring emissions factors for power plants. The curiosity struck me of how do I get this data everywhere? That's sort of the first step in actually trying to tackle this problem. So with that in mind, there's a lot of different methods and very interesting ways of analyzing this data that you can view again for free, because this competition is basically, once the winners have been chosen and given their prizes, everybody sort of presents their data and you can actually view different methods of geospatial analysis. It's very helpful in learning about these topics and how to code this type of stuff. So one method that at the time I wanted to use in the competition, but just didn't know how to execute, was building something called a Voronoi diagram. So QGIS actually has this already built in as a feature. It's very easy to use. How to do that is basically just go right to Vector, Geometry Tools, Voronoi Polygons. And it's almost as easy as just 2 or 3 clicks. So which layer? Power plants layer, a buffer region. So how much outside of this extent do I want to demonstrate? And that's basically your extent is your view. So your current view. So from this point to this point down here, that's the extent. It's actually a word, the vocabulary used for the coding. So I can actually decrease that extent by just zooming in. And it'll take a second to load. So these load times are kind of dependent on your hardware as well. So if you're running on a low RAM machine, you're not going to have a good time if you continuously save these data sets and don't clear them between every request. So that's kind of why I did it that way. Now let's go back to that real quick. Which one? Geometry Tools, Voronoi Polygons. So I don't really care about much of the region outside of this. It's already kind of beyond what I care about. Now, where do I want to where do I want to save this? So let's call this power plant. Oh, I need to give it a file type. So I would like to save this as a GeoJSON. And there we go. So what is this massive pink shape that I just generated? So in very simple terms, Voronoi diagrams are sort of just built with these mathematic principles. And if I put this layer a little bit lower, you can kind of see. So every polygon in this diagram has a centered point that I've given it as each of the power plants. And each of these lines is exactly the same distance between any 2 other points. So every boundary, let's look at this one right here. Every point on this line is equidistant from the next nearest point. So these 2 points, every equidistant point creates this line. Every equidistant point creates this line between these 2 points. So that's really complicated mathematically, but not so much if you just can write the code to generate all that computation immediately. Let's go back to layer properties and make this look a little bit better. And let's also get rid of the US states borders because we don't need those anymore. We already used New York. So if I go to properties here, and one thing that I like to do is decrease the opacity of each of these polygons. So let's bring this one down to like 50% and change this to just sort of a more neutral tone color. Let's go orangish. Now it's easier to see sort of where you are on the map. Actually, I can probably decrease that a bit more. So now you can kind of subtly see these cellular regions for each of these power plants. So my method here, and this is still an ongoing case study that I will be conducting as more satellite images are sent to Google and I can download them. But uh, let's say I just want to identify uh, these emissions plants, so maybe fossil fuels only. And let's look at let's do oil, gas, and coal. Some of these others do have emissions of other sorts, but the ones I care about are these fossil fuels. So I could redefine this diagram to only build cellular regions for these three categories. And that's, you can continue to filter down this way in the tool, but for now, I'll just sort of keep this, this breakdown. And let's zoom in here to New York City. What do we have here? We have some oil refineries and gas, and that's a natural gas. And if I draw sort of just a filter like this, it will select each of these cellular regions that I want to look at more data specifically. I think I had the extents only down to this point, so that kind of leaves off a bit of this area. But for now, we'll go through. So I want to take these areas and only download my emissions data for this particular region.